given a circle, and we're asked to find, in terms of k, the coordinates of the center and the radius of c. So we're going to write it in the general form: x minus a squared plus y minus b squared equals r squared. Radius r, center AB. So we can complete the square. First of all, on x, I'm going to get x plus 3k. I have that 6k squared. This will give me x squared plus 6k x plus 9k squared. So I'm going to need to minus 9k squared as a consequence to keep it all okay. And then over here, very similar, y minus k squared, and then I need to minus k squared. And then I've still got my plus 7 equal to 0. So x plus 3k squared plus y minus k all squared is going to equal 10k squared minus 7. And that means the coordinates of the center C are going to be minus 3k k. I just take, remember in the original it was x minus a, so I have to take the negative of whatever's here. And then the radius is going to be the square root of 10k squared minus 7. Nice. We're then told that the line with equation y equals 2x minus 1 intersects C at two distinct points, and we're asked to find the range of possible values of k. As k varies, the center and the radius is going to vary. Now here's a line that misses the circle, it would have 0 distinct points. This one would be a tangent. It's something like this that we're interested in, where it cuts through in two places. And we can essentially treat it like a simultaneous equation and solve this. And I'm going to go with the original at the same time. We're just going to get a quadratic in x, because I'm going to substitute in for y. But it's also going to contain k. This is where the discriminant is going to come in, because I know that it crosses in two places, and so I can use that to work out k. So let's replace every y in the original equation by 2x minus 1, x squared plus 2x minus 1 squared plus 6kx minus 2k times 2x minus 1 plus 7 is 0. Expand this double bracket, 4x squared minus 4x plus 1 plus 6kx minus 4kx, then plus 2k. Double negative here, be really careful with that. Right, and then I can bring, I'm going to write it as ax squared plus bx plus c equals 0, so I can use the discriminant. So I've got 5x squared, then I've got minus 4x, and then these are my other x terms, so it will be plus 2kx minus 4x. And then finally, I've got 2k plus 7 plus 1, so that's 2k plus 8. Just going to factorize an x out. I'll put it at the end though, so 2k minus 4x, and I've got my single coefficient. And here's my c, I'll put that in a bracket. So here's a, b, and c. B squared minus 4ac is greater than 0 for 2 points, for two distinct intersection points. Therefore, 2k minus 4 squared minus 4 times 5 times 2k plus 8 is going to be greater than 0. And now I've got a quadratic inequality in k. Expand this, we've got 4k squared minus 8k minus 8k, so that's minus 16k plus 16 minus 20 times 2 is 40k, and then 20 times 8 is going to give me minus 160. Right, 4k squared minus 56 minus 144 actually. They each have a factor of 4, so we can divide through by 4. I would advise that. You might be tempted to just put it in your calculator, to be fair, but I'm going to do that. Actually, if you try and factorize it, it's not going to. So in this case, we use our solver, or you can use a quadratic formula, it's up to you. Could go straight for the inequality. There is an inequality function, but I quite like to just solve the equation and draw the graph. I think it's just a bit safer. Like it just shows our understanding. So 7 plus root 85 and 7 minus root 85. With the roots. Then if I draw a little graph, I think it's going to look something like this. I'm looking for where it's greater than 0, so it's above the axis. It's going to be to the right of the upper value and to the left of the lower value. So therefore, overall k is going to be less than 7 minus root 85, the lower one, or k is greater than 7 plus root 85. This will guarantee 2 points of intersection with this line of y equals 2x plus 1. Well done.